I'll go ahead and share my screen and we can get rocking and rolling. Alright, you can see my paper? Perfect. Alright, so let's say we have a problem like this. We're putting money into a bank. Our principal is equal to $2,000. Our interest rate is equal to 7%. What's another way that we can write 7%? Right? 0.07. And it's compounded every 6 months. So at this point, all this looks familiar, right? Cool. We'll say the number of years that we keep this money in the bank for is 10. Okay, so what's the first question that we need to ask ourselves when we're solving this type of problem? And we have to ask ourselves, is the interest compounded more than once per year? Or is it compounded just once per year? Okay, so in this case, the interest is compounded every 6 months, right? Okay, so our first step, we know, is to always write down our equation. Final balance is equal to P1 plus R to the n. So we were talking about this yesterday. If the interest is compounded more than once per year, can we just plug these values in and solve for the answer, or do we need to adjust some of these values? And the two values that we need to adjust are the R values and the N value. So the number of years and the interest rate. Okay, so this is where my little trick comes in. So our first step, do you remember what our first step is in changing these numbers? Okay, good. And so that gives us 0.07. Okay, and what's the next step going to be? Okay, and why do you say 2? Okay, so I think the step that you're talking about is doing 12 months in a year divided by 6 months, right? Which is equal to 2 times per year. Okay, good. So that's our first step. This is step number 1. Okay, now what we're going to do is we're going to take the number that comes out of this first step. We're going to write times 2, or times whatever number is right here, and divide it by 2. Equals and equals. Okay, so the little trick that I came up with is, in order to find our new values, we're going to divide the decimal. So right after this first step, which is always going to be the same if the interest is compounded more than once per year, we're going to divide 12 by however often the interest is compounded. We're going to take whatever number comes out of there. You can highlight it, you can draw a circle around it, you can write it in a different color, whatever is going to make it stand out. You're going to write times 2 divided by 2. And then we're going to remember the decimal is divided, or we divide the decimal. So in this case, which is the decimal? And so there's one number that we have to put in here. And what number is that going to be? Okay, not quite. So dividing the decimal is all we have to do. The the number that we're going to put in the multiplication is the number of years. Right? Because the idea of multiplying this number by 10 is to find the total number of interest periods. So we're using each of our numbers from our problem one time. And so if we've already used the decimal, the other number that we could use is the principal, but the principal's fine. It's not one of our highlighted numbers that we need to change. So the number that's left is our number of years. Does that strategy sort of make sense? Okay. And so what is not making sense about it to you? Just like the whole kind of problems in general? Okay. Well, let's practice this new method and get it really locked down. And that's going to help us a little bit. So let's just finish through right here. This is going to come out to 20 years. This comes out to 0.07 divided by 2. 0.035. These numbers right here are our new R and N values. And these are what we're going to use to plug into our equation. We can say this is our N, this is our R. So let's practice this a little bit. I'm not really worried about plugging into the equation because you've shown that you're pretty good at that already. But let's focus on this specific type of problem. So, let's say we have a principal of $1,000. Our interest rate is 3%. And our number of years is 6. This interest is compounded every 2 months. Okay, so what's our first step always in this type of problem? Sure, that's a good first step. I like writing down the equation as well, just to make sure we know what we're plugging into. So what I liked is it seems like you asked yourself in your head, is the interest compounded more than once per year? And the answer to that was yes, and so you said, okay, we have to change. Or we have to go back to our step number 1 over here, right? So the interest is compounded more than once per year. We can find how many times the interest is compounded per year. Or, sorry, the number of times the interest is compounded per year by doing what divided by what? And that equals 6 times per year. So this is our big number right here. We're going to use this number to change our N value and our R value. Okay, so in the new strategy that I showed you, we're going to write times whatever number comes out of here. We can write a little blank here even, just so we know we have to put a number here. Blank times 6 and blank divided by 6. And remember, our trick is to divide the decimal. So, what's our decimal in this problem? And what value or what letter is this value going to come out to be in this problem? It's our R. So we've taken care of the R value. Have we taken care of the principal? No, but do we actually have to change the principal in this type of problem? Or do we have to do anything, or can we just plug it straight in? So we don't have to worry about the principal. So what's the one letter or one part of this equation that we haven't touched yet? Is the n. So if this takes care of the r right here, this is going to take care of our n. When we're talking about n, what are we talking about? We're talking about the number of years, right? And the number of years in this problem is? 6 times 6 is 36. 0.03 divided by 6 is equal to 0.05. We now have our new r value, and we now have our new n value. Okay. Do you have any questions about this process? Okay. Let's keep practicing it. Let's nail it down and make sure that we could really do this. So, let's say we have a principal of $5,000. Let's say our interest rate is 5%. And our number of years is 2. We'll keep it nice and short. This interest rate is compounded every 3 months. Okay, so immediately off the bat, we're asking ourselves the question, is the interest compounded more than once per year? And if the interest is compounded more than once per year, what do we have to change in our equation? The r and the n. Do we have to do anything to the principal, the p? No. Principal's set. We can put it in its own little box. We don't have to touch this. The two that we're concerned about are these two right here. Okay. What's our first step in changing our r and our n values? Okay, 3 divided by 12. And what number comes out of that? And so what we're solving for, that 0.25 is the number of times per year it's compounded, right? Now, does that make sense? Okay, so if 3 divided by 12 doesn't make sense, let's try 12 divided by 3. Does 4 times per year make sense? I'd agree. So whenever you do this process and you plug in your numbers, just ask yourself, does that make sense? Does it make sense that the interest is compounded more than once per year? No. Okay. Let's try it this way. This is our big number right here. Now we write what? What's our second step? So we're going to write 4 next to our divide and 4 next to our multiply. Okay. And what was our little phrase to remember where to put what number? We're going to divide the decimal. Divide the decimal. That's how we're going to know where to put what. And that's totally fine. The more that we practice this, the more that it's going to get in your brain, and you're going to be able to remember. Okay, so what's our decimal in this case? That's exactly right. Good job. So our decimal is 0.05. What do we do with the decimal? We divide the decimal. Okay, divide the decimal. Good. So we have a number right here. We still have to place a number next to our multiply sign. Okay, 3. And why do you say 3? 2. I agree. Because this number right here is going to give us what letter in our equation? And this equation right here is going to give us which letter? And the way that we can remember that is if there's a decimal in here, we know that that's going to be the R, because we know that that's a percent, right? Okay, so let's go ahead and plug this into our calculator. So our new R value that we're going to plug into our equation is 0.0125, and our new N value that we're going to plug into our equation is 8. Okay, let's try another type, or same type of problem, but let's walk through this process. Or actually, let's do something else. So, whenever you're doing math, do you notice how there's sort of a series of steps that we take? Like, okay, we divide this number by this number, and then we do more math over here and more math over here. But do you notice that this process is the same every single time, just with different numbers? Okay, so a strategy that I like to do, or sort of do you find yourself sort of forgetting those steps as you're going through and saying, okay, what number do I do here, and what number do I do here? Okay. So a strategy, and what I like to do, is I like to write a little cheat sheet for myself where I write down all of the steps in a problem, and if I'm ever doing that type of problem, I can look at it and I can know exactly what to do because this cheat sheet is going to tell me. And the more that we use this cheat sheet to help us, the more that we'll be able to practice the problem, and after a while we'll realize, oh, okay, this goes here, and this goes here. Okay, so let's write a compound interest cheat sheet. Okay, so we know our variables. We have principal, which we call P. We have our interest rate, which we call R, and we call our number of years N. And then we have our final balance. Right? These are the 4 numbers that we're going to be working with when we're doing this type of problem. And I'll send you a copy of this. We're going to be writing these cheat sheets for all the types of problems from now on, just so we have a reference. So I'll send this over to your mom so that you have. Okay, so I like to break the whole problem down into a series of steps. So if we had to decide on a step number 1 for compound interest problems, what would be a good step number 1 that we could take? Yeah, I like that. That's a good first step. Is it compound interest or simple interest? And how do we know if it's compound interest or simple interest? And I think most of the time you're going to be told in the problem if it's compound or simple interest. So how we're going to know is it's going to tell us in the problem. Okay, that's a good step number 1. What would be a good step number 2? Okay, I like that. That's a good step number 2. Divide our interest rate by 100. I like that. What's good step number 3? Yeah, exactly. So decide which numbers are R, N, and P, right? Because we don't know, we can't solve the problem if we don't know where we're putting our numbers. What's a good step 4? Okay, that's good. I think before we do that, we need to ask ourselves the question, is the interest compounded more than once per year? Right, because if the interest is compounded more than once per year, it's going to completely change the way that we do the problem, right? So let's ask ourselves the question, is the interest compounded more than once per year? Okay. So if the answer is no, then we can say, or let's say if it is. So let's say our interest is compounded more than once per year. What's a good step 5? Well, we know that we have to change 2 values, right? So let's write change our R value and N value. Okay. Well, what's our step 6 that's going to let us do step 5? Exactly. Find out how many times the interest is compounded in 1 year. And what's a way that we can show this mathematically using numbers and an equation? Right, so 12 divided by the number of months equals some number, right? And our step 7 can be what? Okay, so we're taking this number right here, the number that comes out of this. If I call this x, is that okay? Can I say, you know, x times or x divided by something and you'll remember that this is x? Okay, let's call it t. I'm going to highlight it yellow, and every time we use this number t, I'm going to highlight it yellow so it's easy to follow. So we're going to take this number t, we're going to write divided by t, and we're going to write times t. And what's our phrase to know where we're going to put each of our numbers? We're going to divide the decimal. So our decimal number is whatever interest rate they give us in the problem. And what number do we multiply t by? So the number that's going to go right here is the number of years. And the number that goes in our here is our decimal. Okay. Now our step number 8. What's a good step number 8? Plug it all in. And when we plug it in, we have to remember to write every step down. Right? And our equation is final balance is equal to P1 plus R times M. So if we make a sheet like this, we can look at this and we can say, okay, I followed step 1, I followed step 2, number 4, number 5, number 6. And instead of having to remember all of these steps in your head,